All right, so lesson 10.2, we're going to continue on with circles, and we're working now, we're going to be talking about arcs, and this can lead into some really interesting things because we'll eventually be thinking of like wheels and the rotations that they can cover and how many rotations per minute, stuff like that. So that's where we're headed. But for right now, just some vocab and terminology. So if we have this circle as they show us, if we have an angle that is formed by 2 points on the outside of the circle and then the central point, meaning our center of our circle, this is considered a central angle. Okay, so that central angle would be written as angle ACB. That would be my central angle, and they have that written there. Then, if it's less than 180, this is considered a minor arc, okay? So that's going to be small, less than 180. Now, we would write that arc AB, write the two letters that form it with the arc sign above it. Now, if we're talking about this same central angle, but I want to reference this arc, which is considered a major arc, the way we define that is using three letters, so ADB. So that third letter helps differentiate it from the minor arc. Okay, now the way we measure arcs, when we have a central angle, the central angle in this case is 50 degrees, then the arc here, this minor arc, is also going to be 50 degrees. So the measure of a minor arc is the measure of its central angle. And we write it with a little m. So the measure of arc AB in this case is 50 degrees. Okay, now we know the entire circle all the way around is 360. So if they want us to figure out the measure of the major arc, the measure of arc ADB, this distance here, we would just do 360 minus 50 and we get 310. Okay, pretty easy up to this point. Let's fill in some of these answers. So these should have a little m in front of them. Measure, if we just want to put an equal sign. So find the measure of each arc at circle P, where RT is a diameter. Okay. So in this case, RS is a central angle, angle RPS is a central angle. So this is 110, so that means RS is going to be 110 degrees as well. Okay, and then measure of angle RTS, so that is going to be this outside region, RTS, my major arc, is going to be 360 minus 110. I don't want to write it like that, but that's where it comes from. So that's going to give me 250 degrees. And last, the measure of angle RST. So this and this and this, since they told us RT is a diameter, that means this is a semicircle. So this is just going to be half of my 360. So this answer here is 180. Excuse me. Letter B, find the measure of each arc. Again, in this case, AB is my diameter. So the measure, if I put a little m in front of these so I can just write equals, the measure of arc AD, because this angle ACD is a central angle, this arc is also the same value, 65 degrees. The measure of arc DAB, so that's going to be DAB, it's all of this. Well, since they told us that this here is the diameter, that means that this arc from here to here, maybe I should use a different color for that. From A to B, this direction is going to be 180. So 65 and 180 is going to give me 245. Okay, and then if I look at my last one, I'll just write it on this side. Oops, 245. Whoa. Sorry, we'll write measure equals, I'm just going to put it here because I can fit it. And then the last one, the measure of arc BDA, well again, since this is a diameter and this was 180, that means this is 180 here. So that's a semicircle. All right, so now we're going to see that, which makes sense. We started the year doing the segment addition postulate and then the angle addition postulate. Now we have the arc addition postulate, which just says if I want the entire measure of arc ABC, okay, they're using three letters, so it must be going in that direction, covering all of them, then I can just add AB plus BC together. Add the two and you get your answer. So in this case, if I want the measure of arc GE, GE is going to be 40. That central angle would make this arc 40 degrees. This central angle makes that 80 degrees. So this entire angle is really the sum of the measure of arc GH plus the measure of arc HE. And each of those values are 40 plus 80. Now you're not going to write it out like this every time, I understand that, but just showing you 120 degrees. Okay? All right, the next one we're not going to write out in such detail, but GEF would be this entire thing. So I'm going to do 120, what we already found, plus 110. 120 plus 110 is going to give me 230. Okay, so 120 plus 110. So the answer here, and again, you should have that M in front of there if you're just going to write it as an answer like that. And last but not least, the measure of arc GF. So the only piece that remains is this here. So if I know the entire value is 360, I can say 360 minus 230, which is going to give me, and these are little degree signs. They write kind of funny, but that gives me 130 degrees. Okay? All right, and find the measure of each arc. We're going to skip this one just for more practice with other things to save time. But moving on, example 3, here's like an application with a circle chart or a pie graph, what you'd like to think of it as. Survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. Here are the results. So find the indicated measure. The measure of arc AC is 29 plus 108. So if we add those together, we're going to get an answer of 137 degrees. Okay, the measure of arc ACD, this entire thing, I can do 137 plus the 83 that they give me for the people that prefer an athlete, and that's 220 degrees. For letter C, we're going ahead and finding the measure of arc ADC, so all of this. So I can add 79 plus 61 plus 83, and there I'm going to get 223. And last but not least, the measure of arc EBD. BD is everything with the exception of this piece here. So an easiest way to do this would obviously be 360 minus 61. And we're going to get 299. All right, so now let's add some things on here. Some theorems. So two circles are congruent circles if and only if, biconditional, a rigid motion, which is either a translation, a reflection, or a rotation, or a composition of rigid motions maps one circle onto another. So if we can slide it somehow, we have equivalent or congruent circles. So here's the theorem. Two circles are congruent circles if and only if they have the same radius. So as long as they have the same radius, they're congruent circles. Seems pretty obvious. So now it says here two arcs are congruent if and only if they have the same measure and they are arcs of the same circle or congruent circles. That's what this theorem is going to say. So in the same circle or in congruent circles, that's critical. It has to be the same size circle. Two minor arcs are congruent if and only if their corresponding central angles are congruent. Now it seems straightforward here. Angle CAB, let's say I make it up and it's maybe it's 40 degrees. Now they have this marked as congruent, so angle DAE, is 40 degrees as well. It makes sense that this arc, the measure of arc CB, is going to be the same value as the measure of arc DE, right? It seems like that. Now that's only the case as long as these central angles are congruent. So if the angles are congruent, the arcs are the same. If the arcs are the same, the angles are congruent, okay? Again, within the same circle or congruent circles. So this is our last bit here. Let's see if these arcs are congruent or not. So we're in the same circle. Our central angle is the same, 80 and 80. So yes, we can say that DC is going to be congruent to EF. And this is by that theorem. Okay? All right, now in this one, we're talking about these arcs here. Well, guess what? Those are not congruent circles. So no, not congruent circles. We don't have congruent circles there, so we can see their different values. Our central angle is the same, They're both 90, but this is going to have a smaller length. And think about if you were to take a piece of string and you would measure it around here and take that same string, these would not measure the same thing. So that makes sense. All right, here we have two congruent circles. We know they're congruent because they have the same radius, marked as congruent. Our central angle is 95. So yes, arc UV is going to be congruent to arc YZ. That should be an arc sign. All right, so theorem, similar circles theorem, all circles are similar. They're not all the same size, they're not all congruent, but they are all similar. All right, and that brings us to the end there, okay? So take a look at the work, see if you have any questions, and check back with me when you're done, okay? Good work.